In this video, you will deploy a minimalistic instance of PostgreSQL alongside a Prometheus exporter, which will extract metrics from PostgreSQL. Then we're going to configure Prometheus to grab these metrics and save them in its time series database so that we can finally access these metrics from Grafana and visualize them in a Grafana dashboard. This video is composed of 5 chapters, and before we dive into any of them, I need to list the prerequisites needed to continue with this video. Number 1, you should have Helm installed and set up on your machine. If not, please check out this article and then come back. Link is inside the video description. And number 2, you should have Prometheus and Grafana installed in your Kubernetes cluster. If not, please check out this video and then come back. Link for that is inside the description as well. And that's it. We can start with chapter 1. All right, let's party. I left you a link to the repository inside of the video description. Make sure that you go to it. Once you do, go ahead and clone this repo inside of whatever directory you want. I'm just going to clone it inside a desktop for convenience. All right, now what I can go ahead and do, oh, there is me, is drag the resources I just cloned. You can do it in whatever editor you want, it doesn't really matter. I'm gonna go ahead and spin up a new terminal session, and let's begin. All right, now the goal of this video is to have an instance of Postgres and an instance of a Postgres exporter that is scraping metrics from Postgres and exposing it at a particular endpoint, which will then be saved into Prometheus for us to visualize in Grafana. I know that was a mouthful, so let's take things step by step. So here I have the resources needed to deploy a very minimalistic instance of Postgres. If you already have Postgres deployed on Kubernetes, then no need to apply these resources. If you were just following along this Prometheus series, then we can deploy a very minimalistic instance of Postgres by applying all of the resources inside of the Postgres folder. All right. And all of these need to be deployed in a namespace called database monitoring. So we need to create this namespace first. kubectl create namespace database monitoring. All right. Let me go ahead and clear the output. Reapply all the resources. All right. So now if I say kubectl get pods-n database monitoring. All right, so now we have PostgreSQL running. How do we scrape metrics from it? That's going to be done using a PostgreSQL exporter that needs to run alongside it. We're going to deploy our exporter using a Helm chart. This Prometheus community Helm repo contains many Helm charts, one of them being the one that we need. So I left you this link inside of the video description. Please make sure to copy it so that we can go ahead and add this repository into our local Helm configuration. We're going to give this repository an alias by which we can easily refer to it. I'm just going to call the alias Prometheus community. You can call it whatever you want. And using this alias, I can search this repository to see if it has the Helm chart that I need to deploy my PostgreSQL exporter. Indeed, it does. It's right over here. And so now, how can I deploy this exporter such that it's configured to scrape metrics from my existing PostgreSQL instance? Well, if you took my Kubernetes course, which if you haven't, I highly recommend that you do, link is in the description, you'll know that Helm streamlines the deployment of very sophisticated software, in this case, the PostgreSQL exporter, because it abstracts away all of the configuration files that are needed to deploy the software, and it just gives you access to a values file with a bunch of default values which you can configure to achieve a deployment that works for you. So if you go to the official Prometheus community GitHub repo, go to Helm chart, and then specifically click on the Helm chart for this exporter, you'll notice it has a templates folder with a bunch of files needed to achieve a deployment. Abstracted away from us, all we have to do is configure the values inside of the values.yaml file. Upon deploying a Helm release, most of these values we're not going to touch, but we are indeed going to configure the connection parameters that are needed for the exporter to connect to our instance of Postgres. So it needs to specify a host that it can use to find our Postgres service. And once it finds the service, we need to tell it the port that Postgres is serving requests on. So this is the first value I need to customize, which I will do inside of my PostgreSQL exporter values.yaml file. So here we specify all of values that we're going to override, and whatever we don't touch, the default will remain. And so what should the host be? Well, first, let's think about the deployment that we have right now. I have a stateful PostgreSQL instance that's currently running, and the service provides internal access to our PostgreSQL instance. So we need our exporter to communicate with the PostgreSQL service, which has the name PostgreSQL. Now, usually this is enough, but in the event that the exporter isn't deployed in the same namespace, database monitoring, we also need to specify the namespace that our service is deployed in. In that case, database monitoring. And then you'll remember from my Kubernetes course that we follow that up with the default suffix service.cluster.local. All right, and once the exporter is able to find our PostgreSQL service, it needs to know which port it's serving requests on. So we can go ahead and modify the port parameter to be 5432, which it already is. Okay, very convenient. And now, once our PostgreSQL exporter connects to our PostgreSQL service, it's going to redirect it to the PostgreSQL pod, but it's going to be denied access unless we give it the credentials that it needs to authenticate against PostgreSQL. Well, this Postgres instance was configured to accept a username of Postgres and a password of password123, but they've both been base64 encoded, which doesn't really matter, because what we can do is modify the username and password that Postgres exporter will use to authenticate towards the target Postgres instance. The username, usually you can write in plain text, but if I'm given the option to grab credentials from a secret, I prefer doing that. So here I have the option to grab the username from a secret, which I prefer doing instead. So we're going to say user secret. All right. And the name of the secret, well, you can grab right over here, but what I want to do is say kubectl get secret-n database monitoring and grab the name from here. And now what I can do is grab the value based on a particular key. I know I can just grab the key from here, Postgres user, but just for the sake of mixing things up, what I'm going to do is say kubectl get, well, let me just rerun this command and then say output it as a YAML. And the key that will map to some value is Postgres user. And now I can grab the password in much the same way. Password secret. Oh, come on. All right. The secret name is PostgreSQL secret, same as this one. And the key I can grab directly from here, which will map to the password value that is needed to authenticate against our PostgreSQL instance. Now, If we deploy our PostgreSQL exporter using this configuration, in theory, it should be able to find our Postgres service, connect to our PostgreSQL pod, which is serving requests on this port, and be able to authenticate using the credentials that are configured in the Postgres secret. Will everything work? Let's find out. Let me clear the output. I'm going to install a new Helm release called Postgres Exporter based on the following Helm chart. And we can steer the deployment of our Postgres exporter using the values that we just configured, Postgres exporter / Postgres exporter values.yaml. And we're going to deploy it inside the same namespace as the Postgres instance itself, just to keep things simple, -n database monitoring. All right, and the deployment was a success. Let me clear the output and say kubectl get pods -n database monitoring. And now we've got two pods. We've got the PostgreSQL instance minding its own business, and we've got the Postgres exporter that's connected to the Postgres instance and is consistently making API calls to it, extracting metrics from it, metrics, statistics, and it's going to expose all of these metrics at its own endpoint where Prometheus can scrape. How do we verify this? Well, just like we use a service to access this pod, we use a service to access this pod. So kubectl get service -n database monitoring. All right, this is the service by which we can access the Postgres exporter. We need to forward its internal port to a host machine port. So kubectl port forward. The service is called the following, and we're going to forward its internal port 80 to a host machine port of 9187. All right, doesn't really matter. And this service is in the namespace -database monitoring. All right, now we can go to localhost 9187. And this is the home page for the Prometheus PostgreSQL exporter. If you see a page like this, then that means it's running fine, but is it able to actually grab metrics? So whenever an exporter grabs metrics from some target app, it usually exposes these metrics at its own metrics endpoint. Here we see a lot of Postgres metrics that it's probably grabbing from this instance. How do we make sure? Well, this is enough of a verification, but there's a particular metric that's interesting called PG up. So is Postgres up? A value of yes means PostgreSQL is up, and our exporter was able to determine that. Beautiful. Now, all of this data the exporter is exporting or exposing at this endpoint, how do we make sure it gets saved into Prometheus? Well, that's where a service monitor comes in. So do we have to deploy our own service monitor to configure Prometheus to find all of this metric data at the exporter's endpoint? Not really, because if you look inside the Helm chart, there is also a service monitor.yaml inside of the templates folder, which means we can steer the creation of that service monitor by modifying some of the values inside of this values.yaml file. The only thing we need to really do is say service monitor enabled true. And one more thing. So if I say service monitor enabled true, that should therefore enable the creation of a service monitor. And now I want to set labels for the service monitor. The label that I need to add is, for my specific case, is release Prometheus. And the reason being is I deployed Prometheus using the kubeprometheus stack. And under that installation, Prometheus is configured to only discover service monitors that have this label. All right, and that's really all I need to do. This will ensure that a service monitor is created and that configures Prometheus to find all of the metric data being exposed at this endpoint. And once Prometheus finds this data, it's going to constantly pull it every 20 or 30 seconds and save it into its database. So now we need to upgrade the Helm release to use these new values. So I'm going to clear the output and I'm going to say Helm upgrade. If you remember, I called the Helm release Postgres Exporter and I created the Helm release based on the following Helm chart. Now we're going to use the updated Postgres Exporter values, -n database monitoring. What the heck? Oh, sorry guys. All right, beautiful. Let me clear the output. Let me make sure that a service monitor was indeed deployed. -n database monitoring. Beautiful, 11 seconds ago. And this service monitor, however it was created, it's currently configuring Prometheus to discover the metrics being exposed by this exporter. So now all of this metric data should be inside of Prometheus. And because we installed Prometheus and Grafana using the Prometheus stack, Grafana automatically has access to the Prometheus data source. So if we deploy this Grafana dashboard, we should see a bunch of PostgreSQL data inside of it. So let's say kubectl apply-f this Grafana dashboard. All right. And then what I can do is say kubectl get services-n monitoring because that's where my Grafana service is. And I'm going to port forward Prometheus Grafana, kubectl port forward the service Prometheus Grafana from port 80 to port 3000 of my local machine. -n monitoring. All right, so now if I go to localhost 3000, and we don't see the PostgreSQL dashboard, and let me explain why. Where did I deploy the dashboard? Did I even deploy it yet? I deployed the dashboard inside of the default namespace. It needs to go inside of the same namespace that Grafana is deployed in. In this case, I have my Grafana deployment inside of the namespace monitoring. And what's essentially going to happen is this label Grafana dashboard 1 allows Grafana to automatically detect this dashboard and import it. So now if you go ahead and apply the same steps, Grafana should now detect the dashboard. There you go. And the fact that we don't see any data in this dashboard, the reason you saw data is because I was running this tutorial an hour ago. And we don't see data in the past 5 minutes. It could just be that Prometheus needs time to scrape this data. We can verify this by accessing the Prometheus UI itself. So let's clear the output. kubectl get services -n monitoring. I want to access the Prometheus UI. So kubectl port forward service/Prometheus operated. We'll keep the ports consistent. -n monitoring. So let's go ahead and say localhost in 9090 and ensure that there is Postgres data. Indeed, there is. I see a lot of Postgres metrics. PG up. Let's execute that. It's set to 1. Everything is working fine. So I wonder why we don't have any data inside of the Grafana dashboard. Let me go ahead and report forward that, but I'm going to start port forwarding in the background because I'm tired of starting and stopping stuff. So port forward Prometheus in the background, port forward Grafana in the background. All right. Let's try this again. I wonder why we're not seeing. Oh,
I just needed to be patient. Sorry, guys. So at least now you get to see that
All the data is indeed being saved into the Prometheus database.
and Grafana, which is connected to the Prometheus data source, is able to grab all the metric data and allow us to visualize it in a Grafana dashboard.
And so by watching this video, you learned how to configure a PostgreSQL Prometheus exporter
To discover an instance of PostgreSQL, extract metric data from it, expose it at a particular endpoint, which Prometheus can pull and save into its time series database, which Grafana can then connect to the Prometheus data source and allow us to visualize those same metrics in a Grafana dashboard. That's all for this video. In the next one, you're going to learn how to monitor a Redis dashboard or MongoDB, depending which one I end up doing.
So I'll see you in the next one.